Hey, what's up everybody? It's Chris. In this video, I'm going to show you guys how to code the magical effect of sine waves. Now for you guys wondering why you should code something like this, any dynamically generated visual you add to your site is going to make it stand out a lot more than if you were to just use something that's static. Now, creating an engaging effect such as a sine wave does not have to be hard, I promise. In fact, it only takes a few lines of code to get the most simple one going. As we learn to create the simplest of sine waves, we're then going to add a controller that allows us to edit all of our sine waves' individual properties, such as its amplitude, its wavelength, and its frequency. This will give us ultimate control over what our final sine wave will look like and opens up so many doors for creativity and experimentation to create something that's truly unique to you. Finally, I'm going to share with you some of my very own canvas secrets that I use pretty much within any canvas piece to make it stand out. Now we're gonna get straight to the how-to and skip over any initial canvas setup. If you're a beginner and you don't know how to set up your canvas, go ahead and check out my series on Canvas for beginners. Otherwise, let's go ahead and fire up our computers and let's get started. So to create a sine wave, the very first thing that we're going to want to do is draw a line from one side of the screen to the other. So let's go ahead and start doing that right now. To create a line, we are going to begin a path. And then we're going to start our path on the very left-hand side of the screen, right in the middle of the y-axis. So we can say we're going to move our cursor to 0. And then to get down right in the middle of the y-axis, we're going to reference our canvas's height divided by 2. And that's going to place us right over here. So now we can draw a line to the other side of the screen by saying c.line2 is equal to our canvas's width, which takes up everything from the left to right hand side of the screen because we declared it right up here. And our y value is also going to be equal to canvas height divided by 2 because we just want a pure straight line. So make sure that you have an uppercase T right here or else this isn't going to work. If you save this, you're still not going to see anything. All that we drew was the path, but now we need to fill this path in. So we can say c.stroke, get some parentheses on the end to call the function, and there we go. We now have a line going from the left to right hand side of the screen. But we have an issue here. We only have two controllable points on this line, the point right over here and the point on the far right hand side. In order to create a sine wave, we need to make sure that every pixel along this line has an editable y coordinate. Right now we only have 2. We probably need about 600 in order to create that sine wave function. So to do this, we are going to create a for loop right after our c.moveTo. And this for loop is going to run once for each pixel along our canvas's width. So we start off at 0. We start adding 1 all the way until we hit the right-hand side of the screen, which is our canvas's width right here. And we want to draw a line each time we run through this for loop. So we can just copy and paste what we had. And instead of referencing that we're drawing a line from one side of the screen at 0 to the other, we're going to draw a line for each individual pixel. Each individual pixel is represented by this I. Since we're increasing I by 1 each time we run through this loop. So if we change this to I and save it, refresh the page, we're going to have the exact same result. But the difference is we can now edit our y value for each point. Think of this as referencing one singular pixel on the screen. So if we start changing this by I as well, our y value, you'll notice that we edited all of our pixels' y coordinates because we put the c.line2 function within a for loop. Let's go ahead and change that back for now. And let's start creating the actual sine wave. So to create a sine wave, we are going to keep our y value the same right now for all of our pixels. But the difference is we are going to be adding a Math.sin function onto this. And this Math.sin function is going to take our I value, which is going to increment each time we run through this for loop. Now, those of you new to the sine function, all a sine function does is it takes a value and outputs one in return. No matter what value you put in here, it can be big, small, 0, -1, 1,000. it's always going to return a value anywhere from -1 to 1. Doesn't matter how big, how small the number is going to be. Whatever number you put inside this function right here, Math.sin will always return a value from -1 to 1. And that's what's going to help us create this sine wave effect, which we'll get into more detail as we go along the process. So if we save this, you'll now see that we're starting to get a small little sine wave effect in there. And we can increase the size of these waves by adding on an amplitude. And to add on amplitude, all we're going to do is we are going to say, multiply everything we have right now by a larger value. And saving that is going to give us a sine wave, but everything here is really tight. We need to elongate these waves. We need to make them nice and smooth. And to do that, we need to affect our waves' wavelength. And to affect our waves' wavelength, we're going to go inside this math.sin function. And instead of just referencing whole integers like we're doing right now, since we're increasing I by 1 all the way until we hit canvas width, we're going to smoothen this out by multiplying I by a decimal. This is going to make sure the number in here is much smaller, which in return is going to give us this nice sine wave effect. The next thing I want us to learn how to do is how to edit these values using some sort of slider. Right now, we're kind of editing these values just by guessing. So if we want really tall waves up here, maybe waves that hit the top of the screen, well, we kind of have to guess what value that would be for our amplitude. And it's kind of annoying because we have to just save, refresh over and over again. And it's not very detailed. We want something in which we can get really granular with these values right here. So what we're going to do is we're going to install a package called dat.gui. And what this is going to allow us to do is provide a really easy way to edit all of our sine waves values and see them change in real time. So once you have added that package, whether it be through yarn, npm, or just pulling the script in directly through a script tag, you can go ahead and import it at the very top. And this import is only going to work if you're using a package manager. If you imported this through a script tag, then you won't need to do this. You can just reference the objects directly. But since we imported it using yarn or npm, we're going to say import all as dat from dat.gui, the package name. And this should not be surrounded by quotations, just a heads up. So now we have the package imported, we can now instantiate a dat object. So to do that, we're going to say const dat is equal to new dat.gui, all uppercase. And we now have a dat object. I think I did something wrong here. Let's go ahead and see. All right, we have a duplicate declaration because we imported things up here, but we're also trying to declare a variable using this newly instantiated object. So rather than saying this is dat, we're just going to call it GUI. And now we have no errors. So we now have this control interface up here, but we need to start adding sliders up here. You're going to see what I mean in a second. First thing first, when using dat.gui, we always create some sort of object that represents our values in here. So our object is going to be a wave object. And our waves properties so far are we have a y value. Let's go ahead and copy this. Y is equal to canvas height divided by 2. We have a wavelength value, which is equal to this value right here, 0.01. Our wavelength is equal to 0.01, and then we have an amplitude value, which is equal to 100. So when using dat.gui, we're always going to create some sort of object and set its properties. All the properties related to this object are going to go right here. Then we're going to call GUI and say add our object right here. And we're going to declare what property we want to be editable by some sort of slider. So our first property is equal to y. And if we save that, you'll now see that we have a new input field up here. And we can edit this input field simply by selecting it and typing in new numbers. But it's a lot more useful to be able to drag from left to right some sort of slider. So we're going to add on the range in which we want the slider to be able to go to. So if we want our sine wave to be able to move from the top to bottom of the screen, well, we need all of the possible y values. So top of the screen is going to be 0. And then our ending range is going to be our canvas's height, because that means we've reached the bottom of the screen. And now you'll see we're starting off at 304 because that's what half of our canvas height is. But we can now move this to 0 to our full canvas height. That's going to make things a lot easier rather than typing in the number directly. So let's go ahead and do this for each value within our wave object. We're going to say our wave's length property should be editable. And we're going to say this value is anywhere from negative 0.01 to 0.01. Then we're going to do the same thing for our amplitude. Amplitude is going to be equal to, it's going to be a little bit larger, it can be negative, it can be positive. So we're going to say start off at negative 300 and then be able to go to 300. We're actually starting off at 100, but this is our range. So now you can see we have a range for length, which gives us really granular numbers over here, and we have a range for amplitude, which gives us something a little larger. Now we can start integrating this so that whenever we edit a value up here, the drawing of our wave is going to react in return. The reason our wave isn't already reacting is because everything that we're using to draw our wave is actually only being called once right now. We're literally just reading this file from top to bottom, calling this, and that's it. We're not calling this over and over and over again, so whenever we change this, nothing is happening. So we want to make sure we're calling something that's being called over and over again so that when we change one of these values, our values on the drawing start to change as well. So to do that, we're going to create an animate function. And inside of this animate function, we are going to request an animation frame. And we are going to call the same animate function within that and make sure to activate the function at the bottom. So we've now created an animation frame. What's happening is each time we run through this function, it's just saying call this function over again. And you'll see if I start console logging out a value in here, it can be any number, any string, it's being called over and over and over again. And this is what's going to allow our wave over here to respond to these values in this slider. So rather than being called once like it is right now, we can move our draw code inside of our animate function. And if you look closely, you can see that based on the jaggedness of this line, that it actually is being drawn over and over again. But still, editing these sliders doesn't actually do anything, because these sliders are changing the values within our wave object, but these values aren't actually being referenced within our draw function. So rather than reference a fixed value such as canvas height divided by 2, we are going to reference the value that's being changed by dat.gui, which is wave.y. So if I save that, refresh, and start editing our y value, you'll now see that it's responding to our slider up here, and we're getting a pretty cool effect. And we can do this for each of our wave's properties. So let's replace 0.01 with wave.length, and then we're going to replace 100 with wave.amplitude. Refresh the page, and now we can start editing pretty much everything here. So we can edit our y value, we can edit our wavelength, which creates a pretty darn cool effect as well. And then we can edit our wave's amplitude. So with just this, we have a lot of potential for creating generative artwork. Make sure you play around with it a bit before proceeding. So since our wave is now inside of an animation loop, let's go ahead and make this wave a little more dynamic, a little cooler, get things moving. To get this moving, we want to add some sort of frequency onto our wave. Frequency is the number of wave cycles that pass a fixed point over time. So to integrate frequency, we want to make sure we're adding a value somewhere that gets our wave moving. Let's go ahead and start off by adding a frequency value to dat.gui so we can edit things later on, and then you'll start to understand a little more in regards to how this frequency is working and pushing our wave from the right to left-hand side of the screen. So we're going to add a frequency property. This is going to be equal to a small value, 0.01. To add a slider up here, we're just going to copy a line. We're going to reference our property of frequency. This is going to be pretty small, so 0.01 to 1. Save that. We now have a frequency option up here. So to get our wave moving, we're going to be adding a value right next to our wave's wavelength inside of the sine function. But we're not just going to be adding 0.01 each time we run through this for loop. You'll see right now that since we just have wave.frequency, nothing is happening. But if we consistently increase this value over time, we're going to start getting that effect of moving from right to left. So to get something in which we're kind of gradually incrementing, we need to create some sort of variable that we'll call increment. And this is going to be equal to our wave's initial frequency. So we can go ahead and replace wave.frequency with increment. But the issue is we're still not adding any value into increment gradually. To do that, we want to say each time we're running through this animate loop. Let's go ahead and add our waves.frequency onto this. And if we save that, you'll start to see we get this effect of our wave moving. That's really all it takes. And same thing goes. As we start to edit all these values down here, they're going to edit in real time. And you can create some really, really nice smooth looking effects with just this. Now, what if we want to be able to see our wave clearly without its lines persisting like they are right now? Well, we want to make sure that we're clearing our canvas each time we draw a new line onto it. So to clear our canvas, we can just say c.clearRect. This is a function that's going to start off with two coordinates, x and y. We're going to start it off the top left-hand side of the screen. How far should we be clearing our canvas? Well, we want to clear the whole thing, so we're going to reference our canvas's width and our canvas's height. And just with that one line of code, refresh the page, and you're going to see that we got rid of the drawing that was happening over and over again. So now let's go ahead and play with the background colors a little bit. Rather than clearing the rect, something I like to do to make canvas pieces really interesting is use fill rect instead. And this is going to allow us to replace our background with a color rather than just clear it completely with a transparent background. So fill rect is going to take the same values, canvas.width, canvas.height, delete clear rect because we're using fill rect now. And we have a black background because we haven't set our fill style. So our fill style is going to be equal to RGBA. And we do want a black background. So we'll say 0, 0, 0. And then our alpha value is going to be equal to 0.01 because that's what's going to create a really nice smooth transition effect. You can kind of see that transition right here. I guess it's more of a fade effect than a transition. But we want to keep on going with this fade effect because it's going to allow our canvas piece to really stand out once we start playing with it a lot more. So we have our fill style with this nice kind of alpha transparent effect, but we want to probably change the color of our line as well to make it stand out more. So we want to change not only our fill style, but our stroke style down here on line 35 as well. So this is going to be equal to, let's start off with hue, saturation, and lightness. Hue is going to be any value from 0 to 255. We'll start off on 0. That should make it red. When we say our saturation is going to be 50%, saturation is a value from 0 to 50%. And then our lightness value is going to be the same thing, just right in the middle, 50%. And with that, we now have a red line compared to the pure black line that we had before. If you want to change the color of this, you can go ahead and change this hue value to anywhere from 0 to 255, and it'll give you a different color. So we're playing with the colors. Let's go ahead and add some sliders for our colors here so we can really fine tune this without having to pretty much delete and replace our values in here manually. So to start adding slider values for our colors, right beneath our wave object, we're also going to create not a wave object, but a color object. And our color object is going to have what values? Well, we have quite a few colors. We have colors referencing our fill style and colors referencing our stroke style. Let's make sure that we differentiate between our background colors and our stroke styles. This isn't just going to be color, this is going to be stroke color. And our stroke color values are equal to H, which is currently 200, saturation, which is equal to 50, and lightness, which is equal to 50 as well. And we can start adding these onto our GUI interface. Rather than referencing our wave object, we could say stroke color. And our stroke color has an H property. And our H property should range anywhere from 0 to 255. This is going to add things right on here, 0 to 255. But things are starting to get kind of cluttered. You'll see that we don't have good separation between our wave properties and our stroke color properties. But we can fix this with dat.gui. So right above GUI.add, the very first one, we are going to create a constant. And this is going to be called wave folder. It's going to be equal to GUI.add folder. The name of this folder is going to be wave. And then we want to make sure that only our wave properties are inside of this folder. So rather than referencing our root GUI object like we are right now, we're just going to replace GUI with wave folder. Save that, refresh, and you'll now see we have a wave folder in the top right hand side. Click it and we have all of our properties. Probably want to open this by default because it's kind of annoying to have to open again each time we refresh the page. So we can say wave folder dot open and then call the function, refresh, it'll be open automatically. So we have a folder for our wave. Let's create a folder for our stroke color. So stroke folder is equal to GUI add folder, stroke, and then our stroke folder, we're going to add our stroke color properties. So if we save that, you're going to see we now have a stroke folder. Let's open it by default, stroke folder dot open, save. And we now have our stroke folder open as well. If we change this value, we're not getting any color change just yet like we are for our wave values. Issue is, we haven't yet integrated our stroke color object into our hue, saturation, light string. So to integrate this in there, we're going to get rid of our fixed value of 200, say $, curly brackets, and then just paste our variable in here. If we save this, we're going to have a broken canvas, or we're just going to lose our color because stroke style doesn't understand this just yet, because we're trying to use this ES6 feature in which we can plop the stroke color value directly in here. To make use of this, we need to make sure we're using backticks rather than single quotations. You'll see that the highlighting changes a little bit once you do that. We save it, and things aren't working just yet because we're not actually referencing H. So we have our object, but we need to make sure that we're calling our H property. And with that, we now have some colors, and we can change those colors now with our slider. Pretty cool stuff. So let's go ahead and do the same thing for our saturation and lightness values. We just go ahead and copy this. Make sure you keep the percentage for the hue and lightness values. This whole reason we're using this kind of cool syntax for which we embed the values. So for our lightness, we'll say .L. For our saturation, .S. Save that. Refresh the page. We still need to add this to our dat.gui stroke folder. So just copy and paste stroke folder. Reference our saturation value. Reference our lightness value. The ranges for saturation and lightness should be anywhere from 0 to 100. So make sure you reference that as well. Everything's already set default at 50. So now when you change these, you'll see that we have a super saturated color now. You go down to 0, there's no saturation. Lightness is now affected too. It's going to change it to white if you go all the way up. Decrease the lightness down to 0 and black. And keep it right at 50 if you'd like. Go ahead and play with the colors. Choose whatever colors are to your liking to create something that's unique to you. Now let's go ahead and integrate our background properties into dat.gui as well. But before we proceed, I challenge you to take this on your own. Try to add some background colors into dat.gui and make sure that the sliders are actually affecting the background color for your canvas piece. Pause the video. Otherwise, once you're done, let's continue. So first thing we want to do is create an object that holds the properties for whatever we're trying to change. So our objects are going to be called background color. And then our properties are going to be R, which is equal to 0, G, which is also equal to 0. Then we got B, 0, and then A is equal to 0.01. Now that we have an object representing our properties, we also need to add a folder to get it displaying within our dat.gui instance. So rather than stroke folder, we're going to call this background folder. And we're not going to reference stroke color, we're referencing our background color. So we can replace these three and then reference our R, G, B values. We also need to reference our A value as well. So create a new line, reference A. And then we need to set our ranges. So G can be anywhere from 0 to 255, B can be anywhere from 0 to 255, A can be anywhere from 0 to 1. And we already have a folder in this GUI by the name of stroke. So we have a bug, and the bug is we named this folder stroke, even though we already have one. This is just going to be called background. So we now have a folder for background with sliders, but nothing's working just yet because we need to integrate these values directly within our fill style. So same deal. We can start off by changing these to backticks. Things are still going to work as we expect them to, but we want to make sure that these values are dynamic. And to do that, we're going to put the values directly within this $sign curly brackets. So we can say background color dot r background color dot g background color b, and then our background color alpha background color dot alpha, which is actually just a. So if we save that, refresh the page, nothing's happening. But if we start to change our values over here, you'll notice that we can change the color of our screen, and we can now start creating really cool color palettes that go along with this. So let's go ahead and start animating our waves values. This is going to give us more of a dynamic effect that just makes our canvas piece even cooler than it is already. So let's say we want to animate our amplitude up and down continuously over time. Well, to do this, we want to use no other than the Math.sin function. If you ever want a value to oscillate back and forth between a set range of numbers, you're almost always going to want to use Math.sin. So multiply whatever value you want oscillated with Math.sin, then make sure that the value you're putting inside of the Math.sin function is always incrementing. So if we put our increment value in there, which is always being added onto because we're always adding on our wave's frequency value, you're going to see we now have more of a dynamic effect. Our wave is being edited by going up and down without us having to do anything. You can do things such as change your color automatically with Math.sin as well. Let's say we want to go between a value of 0 to 255 automatically without us having to do anything. Well, to do that, we can just say our stroke color is going to be multiplied by Math.sin, and then we need some sort of incrementing value. So if we save that, you're going to see that it's starting to increment. It's actually right now oscillating from negative 200 to 200 for a few reasons. One, our hue value is currently set at 200, so that's the max it can go to. Whatever this value is, it's always going to be the max. But the lowest value it can go to is always the opposite of the max, so negative 200. And we can illustrate this just by console logging this out in the terminal. It's pretty helpful just to view the values of things sometimes if you need to see exactly what you're looking at. So if we want to console log this out, save it. You'll see that we're going anywhere from 200, and then we're going all the way back down to negative 200. Thing is, this HSL function only takes anywhere from 0 to 255 for the hue value. So it doesn't really make sense for us to go back to negative 255. What we can do instead is make sure that we're always getting the positive value of this by saying math.abs, which stands for absolute, and that says each time we get a negative value, we're going to turn it into a positive value. So rather than going back down towards negative values, when we hit 0, we're just going to pop back up to a positive value instead. So we can paste this directly into our function right here. And let's get rid of everything, paste that directly in there. And now everything is going to be a lot smoother. Our function is going to work exactly as we expect it to. So we have dynamic color, we have dynamic amplitude. The next step for you is to play around with all of these properties. There's so much you can do here. You already have the ability to tweak things as needed with everything you have in dat.gui, but you can take things even further just by playing with what you have right here. What if rather than multiplying by math.sin, you just want to divide by, I don't know, just say anything that might create some sort of dynamic effect, such as I. This is increasing incrementally. That might make something cool. Let's see it. Okay, so wow, I don't even know what's going on here, but you can see things are dipping off on the end. Let's go ahead and play with our values in here, see if we can get anything cool looking. I'm trying my best. Can move things up and down, that creates a cool effect. Maybe if we divide I by a smaller value, we can get something cool. Or maybe if we multiply it by a bigger value. Sometimes it just takes some playing around with to get something cool. Okay, yeah, that's a lot cooler than we had before. And you can play around with all these values to get just really intriguing effects that you might not get if you haven't played around in the first place. So be sure to play with things and share with me your best creations. Tag Chris Courses on a post that includes a video, screenshot, or link to your very own sine wave piece, and I'll feature the top 10 across all 3 of these social media platforms. Not only that, your piece will also be featured on chriscourses.com, where it'll be viewable for all eyes to see for years to come. I'll be choosing pieces by the end of the month, May 31st, 2019, so you'll have about 2 weeks to get things rolling. Otherwise, hope you enjoyed the video, subscribe, and I'll see you in the next one.